For 9 years, I was an artificial intelligence researcher at Lockheed and NASA from 84 to 93. That was 16 years ago, and since then I've been an economist, a professional economist. I'm very interested in the future and various big things that can happen in the future. And to think about the future, the problem is it explodes into this fog of possibilities, and it's hard to figure out what to focus on. So I like to focus on a few big changes, if I can identify them. I'm interested in combining expert knowledge from different fields, and let me elaborate. There are many different views of a subject, such as economics, or capital asset, or the crisis, or AGI. There are amateur views and expert views. Expert views split into sort of a conventional, usual expert views, and then non-conventional, alternative expert views. And amateur views often split into the kind of view you might have with a subject if you're just having fun watching a movie or shooting bull, or the kind of view you would have if you were a serious person pontificating, talking to the public, or writing a newspaper article or column or something like that. And we can think about the interaction of social science or economics and artificial intelligence through the following sort of table. The question here is, what are the social implications of artificial intelligence? And what are the possible policies we might introduce to respond to those social implications? And what would the consequences of those policies be? And in this, we can have sort of intersections of fun views. So most movies say we're sort of taking a very ordinary, amateur, fun view of social science and a fun view of AI and combining it into science fiction. Or you could, say, take somebody who knew a fair bit about AI and have them combine with sort of a fun perspective. You might think about How to Survive a Robot Uprising as that sort of a book. You can see sort of serious discussions in newspapers or policy forums, but that are sort of taking an amateur point of view that you might see in the newspapers. And when we get to sort of people who actually know what they're talking about at some level, some sort of experts, we often have, say, somebody who knows AI try to speculate about the social implications, but without having that much of an expert knowledge of the social science. I'll put that as some of you guys here. And sometimes you'll get, say, an economist who'll be asked to respond to speculations about future robots or something, and they will usually say nothing because, in a sense, the usual serious public, amateur perspective on robots is it's kind of a silly thing. It's the kind of thing you talk about if you're having fun in a silly sort of mode, but once you get into serious discussion, it's not a serious topic. So people who know their social science, who are asked to speculate about this subject, basically say nothing because it doesn't sound, it's not the serious sort of thing you talk about. And then there are people over here who take the AI seriously and who have enough sense of the subject to know that, in fact, some sort of robots are coming at some point in the foreseeable future. And then they sort of take some sort of a serious perspective on, maybe they read a book or an article or two or something, and they try to put that together. But that falls short of expert standards, and this red bullet is what we need. What we really need are people who have an expert quality knowledge of social science and an expert quality knowledge of AI, and to combine it together. We need that more than we need people who actually are willing to spend a lot of time thinking about this and sort of go take on some unusual point of view and say, well, I think the regular economists are all wrong and this guy is right over here, or I think the regular AI researchers are all wrong and this guy is right over here. And there might be we need some of that, but we mostly need just the very simple thing of taking the standard conventional points of view in both fields and combining them together to get insights about what's likely to happen and what are the possible implications and what are the possible policies. That's the thing we most need, and we hardly have, because basically, so I'm talking here to mostly you guys, so I'll basically say learning econ takes a little bit more than reading a book. It's more than, say, learning, fractal image decompression by reading a book, or learning how to do croqueting or maybe windsurfing. It's just more work than that. And if you want to get up to speed, you're going to have to spend more time and effort digging in. So the one thing I want to say that I hope you walk away from this is that social science really exists. Now, when I was a physicist once long ago, at least I got a physics degree and I published a few things. And the physicist worldview was there was no such thing as social science. It didn't exist. There were these people over there, and they thought they knew something, but they didn't really know anything, because they didn't have sort of the physicist's hard science approach and knowledge. And so the physicists believed that any sort of speculation that popped into their head about social science was equally valid with anything any expert would come up with, because there wasn't any such thing. And many technologists have picked up that point of view that there is no such thing as social science. Nobody really knows anything. And I'm here to tell you that's just not true. I was one of those technologists. I was skeptical, but I got sucked in, and I eventually had to admit they knew a lot. Now we know a lot. I'm telling you, we know things. So if you have a technology and you want to anticipate its social consequences, you might do well to ask social scientists who have spent their lives studying that sort of a thing. So in particular, speaking about economics, we can tell you about the following sorts of things. Now the check mark indicates how good we are at telling you about these sorts of things. If you want to know about a tech social implications given weak regulation, we're really good at that because economists are really good at thinking through the consequences of weak regulation. Not to say that we're always in favor of weak regulation, but the space of possible regulations is huge, and we basically have to take them one at a time and say, okay, given this possible set of regulations, let's work through our theory to figure out what the consequences are. That means it's harder to speak in general about a wide class of possible regulations. We're even capable at some level of taking some particular regulations that might exist and asking, in a political climate, how likely would those regulations be to arise? Because we do know some things about political science. We might even know some things, although a lot less, about what likely political climates might arise given other sorts of social context. If you're thinking about an innovation or a technology that takes social support to arise, that it takes researchers and development and companies trying to try products with customers who are responding, we can even tell you a fair bit about that. We can tell you about what kind of social support you should expect for any particular innovation given the regime of property rights and incentives in the market you can sell it to, the kind of products you can make. And the thing, in a sense, social scientists would know the least about would be, given that you've got the right sort of social support for it, and you've got all these people paid to do these things about the technology, what will the technology actually do in terms of developing? That would be a technologist's expertise to say what is technically possible given various kinds of funding and support. But we can tell you a lot about the rest of the stuff. That's my main message here. But I did say you have to translate the technology into the standard terminology that we use. That's my job, and anybody's job who's trying to use all the technology, all the machinery and insights that we have to understand what a technology would do. We have to we can't just say, well, it's made out of silver and it's about this high and it's this heavy and it lasts this long. Those aren't very useful. We have to talk in terms of how the technology affects people, in terms of what do people want, what products and services that people want will the technology impact, how will it change the ability to make those products in terms of costs and the combinations of things, who has the ingredients necessary to make this product, where do they come from, how much do they cost, who knows what about the technology and about the quality of the products and things like that, what sort of deals are allowed, what sort of things can be traded and can't be traded, contracts and forms. Once we know these sorts of things about the technology, then we can tell you a lot about what the technology can do, would do under various regulatory alternatives, what kind of social support it would have, that sort of thing. So this is all abstract claims, so I guess I should make this, so I'm going to spend the rest of my time here trying to make this clear that we can come up with insights by telling you some of the insights that we have. But my biggest claim is I could give you a lot more if there were economists who were actually working on this stuff instead of doing it once every few years as a sideline, because that's all there is at the moment. All right, so the economics of robots is something that economists have talked about since at least 1821. This is old stuff. The very first literature on the economics of robots thought of machines as direct replacements for humans. And this was Ricardo, has a famous paper from long ago. He does a decent analysis of the sort that we wouldn't mind at all, given his assumptions, back from 1821. And the prediction is straightforward. If you can have machines that are cheaper than people, that replace people directly, substitute, then wages fall to those machines' cost. And you have many of the sort of elements of most science fiction scenarios about robots replacing people. However, it's now almost 200 years after 1821, and a lot has happened since then. Economists have done a lot of thinking, and economists have come to see most automation as a complement to human labor. So substitute and complement is a key economic concept that we use all over the place. A complement, A complements B, or X complements Y. When you have more of X, you want more of Y. Like left shoes and right shoes are complements. I don't want a right shoe unless I also have a left shoe. Other things are substitutes. So sandals and shoes tend to be substitutes. If I've got shoes, I don't want sandals so much. If I've got sandals, I don't want shoes so much. So are robots and human laborers complements or substitutes is a key technical question, because with the introduction of more and more automation, human wages have risen dramatically. Most economists have said, therefore, it looks like automation is mostly a complement to human labor, not a substitute. So the old substitution scenarios are just invalid and inappropriate. And that's been a conventional wisdom in economics for quite some time. Okay, so are robots a substitute or a complement? So I want to introduce a slightly more complicated point of view that allows it to be both in a way that you can understand. And so that realizes both types. So the way I want to think about this is to say the kinds of things you want done in the world, especially mental tasks, can be spread out along a line. We can spread along the line by sorting them by their human advantage. So given any particular machine and any particular person, there are some kinds of tasks where people are just better at those tasks relative to the machines, and others where the machines are better than people. We just sort them like this. And then what we have is this, like a landscape here, and then we've got this ocean of water here, which represents how good machines are now. And there's some cutoff point where this is about where, at current wages and prices for the machines, the two things are about the same. And on the left-hand side, these are things where it's cheaper to use machines, and these are things where it's cheaper to use people. And the idea is, if machines are improving faster than people are, which they have been for quite some time, then this flood is rising. And this cutoff point is moving. So the key point here is humans and robots substitute on each task, but tasks are complements. So the fact that one task is done better means we can do all the other tasks doing well are great too. So if we can transport people faster from one place to another, then having them in another place is all the more valuable. The sort of things we can make and transport become all the more valuable because we can transport them, etc. So this is a way to understand how they are both substitutes and complements, and in a way we can think about the rising tide and the effects it has. So when the tide is down here at a low level, the main effect of improving machines is that even though they substitute a little bit, there's a little effect of that. Mainly they do all these tasks better and make all the other tasks more valuable. So in this regime, making machines better makes human wages rise. But if you reach a flat landscape like this, and you get way over here, then in this regime, you can have situations where the main effect is a substitute effect, where rapidly machines are replacing and human wages can fall, and whether human wages end up falling or rise in the end depends on the shape of this last hill here. If there's a last few things that people desperately want done by other people, and they're willing to pay enough for them, then human wages can stay high, otherwise they fall. But in any case, most income comes from somewhere else. Another thing to say in terms of insights we have about these, first of all, I say, we tend to make mathematical models. We're that sort of social scientists. That's what economists are. But we make relatively simple models, and we care a lot about exactly what we put in them. I'm not going to explain this model to you, more than to say we abstract an economy to things like the amount of labor, the amount of capital, human capital, and then how much people are consuming for C, and adding it up into a total income, and we can get growth rates in these various things, and we try to fit together a model of how these growths would increase. And we can actually, in this sort of group thing, set up this model I'm just talking about, where there's this landscape of tasks where we get a substitution, and we get one regime, the early regime, where we have familiar growth rates, and then we get a later regime, when the robots dominate, we get a different growth rate. And the key point is the growth rate can be much higher in the later regime. So most people who talk about future robots and them taking over simply neglect, I think, or even to consider or imagine how it might affect overall growth rates. In fact, growth rates can go up by an enormous degree. And it depends on the kind of models you do, but setting in various numbers, you can get a huge increase in the growth rate in the doubling time. So I'm not going to actually give you these numbers, but I want to give you another context about this. So this is a data set going back about 2 million years, estimating sort of the total ability of the world economy to make stuff that people like. Now, through most of that time, it was basically tracking population because people had a basically subsistence income level up until a few hundred years ago. And then in the last few hundred years, we've been able to make stuff faster than we can make people, and so per capita income has increased. We have some decent empirical fits that do a decent job of fitting this curve. And let me just show you what those look like. Over the long term, the big picture looks like the following. So this is years before 2050 as a log graph, which is somewhat arbitrary, so we can fit all these different regimes on the same thing. And then the vertical graph, we have the growth rate, the annual growth rate in the economy. And from about 2 million years ago, we had basically a steady growth rate in the economy for a long time, up until about the farming transition of about 10,000 years ago, where the growth rate suddenly jumped by an enormous factor. And then we had a relatively steady growth rate up until the Industrial Revolution, where now we have a relatively steady growth rate, and the question is, could we see something like that again? And if so, what would cause that? So putting those in numerical terms, there's actually, if you go back farther, if you want to look for a predecessor, animal brains were growing at a very slow rate, since 500 million years ago, up until humans have some sort of important brain innovation that allowed us to grow a lot faster and do important things. I'm sorry. So brains doubled about every 34 million years. Every 250,000 years, the hunting humans doubled. About every 1,000 years, farming humans doubled. And from 15 to 6 years, depending on where in that curve you're going, the Industrial Revolution is doubling. And the question is, what would a new mode look like? And the factors by which these increased were enormous factors, and so at the very smallest of these last 3 factors, you get a doubling time of less than 2 weeks, which is a very fast growth rate. And in fact, if you took various kinds of ways of projecting basically how long the previous mode lasted in terms of doubling time to ask when the next transition gave, you get dates like this predicting when the next transition will be. Of course, some of those dates are past. Some of them are still to come, but they're not that far away. So I would say this is an empirical prediction of roughly sometime in the next century, a transition to a growth rate of another 150 or 200 times faster than now, which would be a doubling time of 1 to 2 weeks in the economy. What would that look like? If the transition was as smooth as the last transition, which was relatively smooth, you'd have, say, an economy that was growing 6.1% in 2040, 6.1% in 2039. 2040, when it grows 6.6%, but that's within the usual fluctuations. Even up to 8% the next year is also pretty much within the usual fluctuations. But then the next year, 14, 40, 147, 400,000, it just explodes within a short period of a few years. That's the kind of transition you would expect from this previous data. That's basically just an empirical projection. What could cause such a dramatic thing? If you think about various kinds of futuristic things people project, mostly they are things that have a very small fraction of the economy. Even energy, construction, even manufacturing is a pretty small fraction of the economy. So even a vast improvement in manufacturing, such as nanotech, it's actually somewhat hard to see how it could cause these sorts of dramatic improvements. But the human, labor and human capital share of income is huge. If you can do something to lower the cost of that or make that grow faster, that has an enormous possibility to make stuff better. So what I've done so far in the talk is I've said there is such a thing as social science. If you want to be able to predict the future of robots and how it affects the economy and the various policy options, you really need to take an expert point of view on AI and an expert point of view on social science to combine them. I've tried to give you some examples of theoretical insights, the complement versus substitutes, how you can do that, some data set about growth in the past, the little math models kind of try to accommodate that and give us that understanding. Now I'm going to sort of just quickly review some of the qualitative implications that I would see as using just a simple, straightforward social science as some of the consequences of what a robot economy looks like, an economy with some form of artificial intelligence, whatever it is. And then I want to open it up for questions because I expect this will be a lively discussion. So first of all, so some of this stuff is stuff you already know just from being a technologist and having thought about it, but it has important social implications. So first right off, immortality is potentially possible if you can afford it, but whether or not the typical creature in this economy can afford that is an open question.
Immortality for robots or for humans?
I can't hear you?
For humans or for robots?
for whoever is a robot. Immortality for the robots. So I'm, in a sense, I am focusing on the robots, and so this is an economy full of robots. They are the most productive thing in the economy. They are dominating the economy. There may be a few humans off on some marginal side, but when I want to do the analysis, I need to focus on the dominant part of the economy, which is the robots.
But I can't kill a robot.
You could say again?
But I can't kill a robot.
I presume you're the technologist, but that was my understanding from when I was in that research. It looked to me like killing, yeah. But nevertheless, potentially, they can have backups and potential immortality at some expense, and the question is how expensive is that relative to the actual wages and income that they have. Robot, can travel interestingly and cheaply by basically transmitting transmitting the bits that represent them some way rather than moving their body, and that has a lot of interesting and important economic implications because cost of travel is a very important element in a lot of standard economic models. Nature, which we're very fond of and now very reliant on, the robots don't need so much. If we have a robot economy of the sort most people imagine, nature may be preserved because somebody wants it, but it isn't needed quite so much. And so the economy may slight it, depending on who wants what. Clearly, the robots can have a wide variety of bodies, even a wide variety of mental abilities, even such a trivial variation as just running at different speeds. So it's a world of gods and peons much more than our world in terms of our familiar human world. These things can vary a lot more in intrinsic capabilities. Much more able to survive in severe environments. And as these robots get cheaper, usually we have a choice in most tasks. We have tools and we have labor. And as people have gotten more expensive, we've had more of a premium on better tools to support them because people are very expensive. As the labor gets cheaper, then we're going to slight the tools more. We're just going to have labor-intensive approaches to doing things because tools are ending up being more relatively expensive as the labor gets cheaper. And a very important element is that copying these things seems to become cheap under almost any imagined robot scenario. Copying a robot seems to be cheap in the sense of taking what is the essential knowledge and experience of that robot and making another version of it. And that has enormous implications not only for economic growth, but for a variety of other things. At the moment, one of the major limitations on the growth rate of our economy is the fact that we only grow people at a relatively slow speed. We don't make them that fast. That's why per capita wealth can rise so quickly. When per capita wealth, when the population can rise as fast as the economy wants it to, that will be a very fast rise in population, almost a Malthusian one, wherein per capita wages of these robots fall quickly to subsistence level, at least under a low regulation scenario, which I said is the thing we can most reliably analyze. And human wages would fall to that same level depending on the degree of substitutability of the human labor and the robot labor in terms of that last hill of the landscape. It's possible to have draconian population or wage laws that limit this somewhat, but they really do have to be very draconian, and you have to be very fierce about enforcing them. And that's the question of how far you want to go down that route. Humans, of course, in this scenario become eclipsed, at least ordinary humans. Obviously, enhanced humans who become competitive in this world of robots could be a substantial element, but then they are not very human anymore, at least in many familiar senses. Whatever remaining eclipsed humans are could be very rich as long as they retained almost any non-wage assets, because this is an enormously rich economy growing at an enormous rate. They couldn't, if the economy is doubling every week, well, their returns double every week. So it doesn't take very long for that to add up to a whole lot. But of course, this huge income by today's standards doesn't let you live in the middle of those cities. Those are going to be a competition for being in the prime areas in this new economy, and marginalized people will have to live on the margins of this world, even if it's a very rich and luxurious existence by today's standards. Almost everybody worries about human and robot wars. We have a vast literature on war and the causes of war and conflict. And the simplest thing to say, of course we can talk more, is that there are an enormous number of divisions within our societies that almost never give rise to war. Left-handed people don't go fighting right-handed people, blonde people don't, etc. So it's a matter of they'd have to have a separation in the society where that was a very salient distinction. People were separated more in terms of who related to who and what associations there were in order to make that salient enough and vivid enough that you might have a war based on that. And so, of course, recommend against that.
Wars between robots?
Excuse me?
Wars between robots?
Of course, since they're the dominant part of the economy, then whatever wars there would be mostly between them. But they would be along whatever divisions were the sorts of political divisions and social divisions that would be the sort that cause war. There are wars, and I expect wars to continue. They just would be, they aren't along every possible dimension. They tend to be along a particular set of very salient dimensions. I have more things I can say here. And I will, I guess, if I have more time, but I'm feeling like there's going to be a lot of discussion here, a lot of conversation. So I expect that rather than continue on with this sort of thing, we should start the conversation. Is that acceptable?
Yeah, you have a single time if you want to talk, but...
Right, but I think we're going to go a long way here, so I'll take the option to go back into speech mode if I see that there's some common sort of thread here.
Okay.